All right, in this last example, at least I think it's our last example, we're going to determine congruence. Is the pair of objects congruent? If the pair of objects is congruent, describe a composition of rigid motions, or if it's a single rigid motion, that's okay too, that maps one onto the other. So here we have these puzzle pieces. Is there a rigid motion or a composition of rigid motions that maps one to the other? So we kind of want to look for, I've got this guy that kind of looks like this guy. I've got this guy up here that looks like that guy up there. So that's making me think maybe reflection. Here we have an opening. If I reflect across, am I matching that opening right there? And then same thing here and here. So this looks like if there was a vertical line of reflection, one object would map onto the other object. So we would say that yes, these are congruent because a reflection across a vertical line maps one puzzle piece to the other. And we'll just make a note, we had a reflection. That was our rigid motion. All right, moving on to our next example. At first glance, this looks like, hey, if we just translated to the right, this looks like this. But what we want to be careful about is have we preserved size and angle measure. So if we look at, let's say, if you notice we've got this diagonal right here. If I find that same diagonal and the other object is at the same length, and I think it's close, but it's pretty clear that these are not the same length. So that means that the frames, like the corners, this is a corner of a frame, it did not preserve length. So these frame corners are not congruent. There is no rigid motion to get from here to here because it did not preserve length. Maybe in parentheses we'll put length was not preserved. All right, our last one, are these two figures congruent? That means, does it map onto itself after a rigid motion or a composition of rigid motions? So all of these inside parts, these would have to all line up over here after the rigid motion. So first I might check to see, do we have a reflection? I could imagine a vertical line right here. Is this red square, and I tend to focus on one part of the picture. If I reflect this red square across, it would be over here. So I would say there's not a reflection to start with. Let's see if we can think through other rigid motions. How about a rotation? So the red square rectangle is here and it ended up over here. That makes me consider, oh, did it just rotate? How much did it rotate to go from this location to this location? And that looks like just a 90-degree rotation. So if that rotates 90 degrees, this might be kind of hard to see because I'm going to draw over these colors. That red rectangle would now be right here. Maybe I'll color it in. Now it's kind of not the best, but hopefully you get the idea. Now, can I do a rigid motion, a transformation, to get this mapped onto this? Now I can see, yeah, reflection might do that. Just have a vertical reflection down the middle. I think this would map across over to this. And if it did map across, is everything else in the same positioning as it was to the red rectangle? So if I go back to, I'm going to erase that and just double check, you've got your you got your red rectangle with this little blue guy. Red rectangle next to the little blue guy with kind of this green one right there. So it looks to me like everything is in the same spot, but it just required a rotation of 90 degrees. I guess I'm not sure what the center of rotation. So maybe I'll just write it out in words because we don't have a center of rotation on this. I guess it would be the center of the square, but so if we rotate 90 degrees clockwise, then did a reflection across the vertical line, we would map this figure onto this figure. So because a composition of rigid motions got us mapped onto the other figure, that means that they are congruent. We were able to find that composition of rigid motions to make that work.